All right, so Bismillah ar-Rahman ar-Rahim. So the slides, these slides have been used from the CCNA material by Cisco, but I have modified these slides significantly, and of course, these slides are posted on Blackboard. So this chapter is very general, and it talks about how important networks are in our daily life. Okay, so networks allow us to be globally connected. Okay? We talk about the concepts of LANs and WANs and what are the difference between these, and we talk about the network as a platform, which means that network at the end is a group of hardware and software. What is the hardware? What is the software, and so on. And how networks are dynamic in a way that facilitates our daily life and work and so on. Okay. So for globally connected, we notice here from this graph that the number of years where the devices on the internet double. At the beginning, from 1995, it was like every 13 years, the number of devices doubled. But later on, we noticed that these 13 years have become 1.4 years. So every 1.4 years, the number of devices double. And then in the future, we don't know. Maybe every like 2 months, the devices will double. So we talk about Internet of Things and things like that, that will allow even our clothes and our shoes and everything is gonna connect to the internet. So which means that one human being is gonna have potentially tens of devices, just walking with tens of devices that are connected on the internet. So of course this is based on the Moore's law. Moore's law is an interesting law. I'm not sure if some of you is aware of Moore's law. Moore is actually the founder of Intel. Okay, and this guy has observed the fact that the number of transistors on 1 square inch doubles every around 2 years. Okay, and of course this facilitates the explosion of hardware devices, which also facilitates how networks can grow exponentially and how they can allow people to not only communicate locally but globally. So nowadays we can easily open WhatsApp and call somebody in China for free. Okay, pretty much for free if you are on Wi-Fi. So how does this happen? What is the history of this? How this get evolved from the past to nowadays? That's what we are going to go in this course. So as I said, globally, we can talk to each other as if we are in the same room. So this is, of course, Cisco. They cannot just leave the chance without embedding their technology. So this is what they call Cisco TelePresence. So by TelePresence, you see a round table with some people meeting. So the guys on the TV, they might be in any parts of the world, and they are sitting on the same round table. And in some cases, they can shake each other virtually, and they can meet as if they are meeting in the same room on the same round table. So this is facilitated by networks and the internet. So that's why networks, they support our way to learn, our way of life, our way to how to work, and even how to play with games. So nowadays games have become widely available, peer-to-peer games and stuff like that, that many people can work and interact in the same game. So network starts from a very small house where you have a bunch of devices that communicate together, and you can share these devices and the resources on these devices. So you can, from any computer at home, you can access the hard drive on any other computer at home. Okay, so all the resources with the network, all the resources, they become available to any device, whether in a small area or in a fairly large area like an office or a building or eventually the entire world. which is what we call the wide area network, which covers very, very large geographical space. So the way that these devices are organized on the internet, some of these devices, we call them servers, and some of these devices are, we call them clients. Servers are mainly fixed, usually very large-scale devices that are put in a fixed place, and as we will talk about in the future, they have fixed IP address and they have fixed network, and they usually support very fast speeds, and they provide certain service. Like, for example, YouTube. When you play any video on YouTube, what happens is that you connect on one YouTube server, which is distributed across the world. So you can connect to any of these servers, fetch the content of a specific video, and play it at your device. So these servers, usually, they are centralized big devices that are fixed and put somewhere. Whereas clients usually are our small scale devices, like a cell phone or our laptop, which can usually move from one place to another, and they are portable, mobile, and things like that. And at any point in time, you can connect to any server and get service. Whether this service is playing video, downloading a file, uploading a file, something like that. We'll talk about all these possibilities for client and server architecture. Also, there is the concept of peer-to-peer. For peer-to-peer, all the devices are the same. There is no centralized thing. There is no fixed server that we connect to. No, we connect to each other. And the best example for this is Bluetooth, and how we can share files peer-to-peer without having to have any back-end server that we both connect to. Okay, so using client and server architecture, if we need to share anything, then I have to connect to the server, put a file, and then you have to connect to the server and get this file. Okay, by peer-to-peer, we don't have to do that. We can connect directly to each other, and without the engagement of a server. Of course, this has some implication. Of course, this is easier to use because we don't need to have a server. And usually a server is a big infrastructure or a big device that we both connect to. So for peer-to-peer, we don't have to have a server. So it's less complex. I don't have to set up a server. It's lower cost because the server, setting up a server is very high cost. And it can be used for simple tasks such as transferring files, and that's what happens. I'm not sure if any of you have used BitTorrent or eMule and these things. These kind of software applications, they use the peer-to-peer architecture. They don't use client-server, okay? So they facilitate the users to connect to each other without any engagement of any server. And that's why it's even legally very challenging to put any lawsuits on BitTorrent. And that's why they use BitTorrent to share files illegally, because there is no specific server that hosts this file. Okay, so if you put any lawsuits against them, they would say, we were not storing anything. We're just facilitating the users to connect to each other, but we're not storing any files in a centralized way. Therefore, we're not hosting any content, and we're not, liable for anything. Okay. However, the peer-to-peer sometimes has some disadvantages. So not having a centralized administration usually make the work challenging, and we'll know why. Okay, so there are some advantages for not having a centralized administration, and we'll talk about that. It's not as secure because anyone can connect to anyone. The fact that I can download a file from any person in China without knowing him, okay, there is a risk that I can download a harmful virus and I can damage my client. Okay. It's not scalable in the sense that these devices are usually small with low capabilities, so I cannot host many files on this small device, right? Whereas servers are very huge, very large scale, so I can host huge amount of content on these devices, which allows many users to connect to this server and download these files. Whereas for peer-to-peer, these devices are usually small scale, so I cannot host many content on these devices. And devices now have to act as server and client at the same time. For peer-to-peer, and again, we'll go through this again later on. For peer-to-peer, each device is a client and a server at the same time, because a client is the one that initiates the communication by connecting to the server. And the server is the one that gives the service to the client. Peer-to-peer, because there's no centralized server, each one has to connect and has to act as a server at the same time. So I can give files to someone, or I can take files from that person. And any one of us can start the communication at any point in time. Okay? So there is no fixed server. The fact that all the peers or all these devices, they can work as client and servers at the same time is an extra load for these machines. Because usually if my machine works as a client only, okay, then I always initiate the communication and I get the service from the server. But if I'm working in a peer-to-peer way, then I can get some service or I can give some service, both. So this puts extra load on me, okay? So peer-to-peer devices, the software, that's why BitTorrent software is a little bit heavy. Okay? If you download like an FTP client, or even YouTube, and your device works only as a client, then it's lightweight. But BitTorrent, which works on peer-to-peer, sometimes you can see the resources on your CPU, the resources are consumed quite a bit. Why? Because you are trying to connect to some people, and at the same time, people are trying to connect to you. So this consumes more resources on your machine. Someone in China is downloading files from your device and you don't know, and at the same time you're trying to download files from some people in here or there. So the fact that both bidirectionally it's working concurrently, this puts more load on your device, and that's why for peer-to-peer software it's pretty heavy compared to a client, like a browser or an FTP client or a Telnet client. Okay? Any questions? So as I said, this